All right, let's dive right into the fascinating world of culinary science, starting with the science of heat transfer. Now, if you've ever cooked anything, and I'm guessing you've um, you've participated in heat transfer. It's fundamental to every cooking method, from baking to boiling to grilling. Now, heat transfer might sound like a complex term, but it's really quite simple. It's just the process of heat moving from one place to another. In cooking, that usually means from your oven, stove, or grill into your food. So let's break it down further. There are three types of heat transfer: conduction, convection, and radiation. Conduction is the direct transfer of heat from one substance to another. Think about it. When you're cooking a steak in a pan, the heat moves from the hot pan directly into the steak. That's conduction. Next up, we have convection. This is the transfer of heat through a fluid, which in cooking can be a liquid like boiling water, or a gas like the hot air in your oven. When you're boiling pasta, the heat from the stove heats the water, which then cooks the pasta. That's convection. Finally, we've got radiation. Now, this might sound a bit scary, but it's really not. Radiation is simply the transfer of heat through electromagnetic waves. When you're grilling, the heat from the glowing coals or gas flames cooks your food, even though it's not directly touching it. That's radiation. Understanding how these different types of heat transfer work can make you a more effective cook. For example, knowing that convection is more efficient than conduction might lead you to bake your potatoes in the oven rather than pan frying them. Or understanding that radiation provides a higher heat than conduction could lead you to grill your steak for a nice sear rather than pan frying it. So there you have it, the science of heat transfer simplified. The next time you cook, think about which type of heat transfer you're using. You might be surprised at how much it informs your cooking techniques. Let's start talking about something delicious that happens in the kitchen. It's a process you might be familiar with if you've ever savored the sweet depth of caramel or enjoyed the rich brown crust of a perfectly baked loaf of bread. Caramelization is a type of non-enzymatic browning reaction. In simpler terms, it's a chemical reaction that occurs when sugars are heated, resulting in a distinctive brown color and a complex sweet flavor profile. When you heat sugar, it first melts into a clear liquid. Then, as the temperature continues to rise, the sugar breaks down into compounds, including glucose and fructose. These compounds further break down into other compounds, and so on. This process creates a cascade of new flavors and aromas, which we perceive as that toasty, sweet, complex note in caramelized foods. Now, there are a few factors that influence caramelization. The first, obviously, is heat. Caramelization starts around 340 degrees Fahrenheit, 170 degrees Celsius, and the higher the heat, the faster the reaction. But be careful. If the heat is too high, the sugar can burn and turn bitter. The second factor is the type of sugar. Different sugars have different caramelization points and produce slightly different flavors when caramelized. For example, fructose caramelizes at a lower temperature than glucose, and may be producing a sweeter, more complex flavor. Finally, the presence of other ingredients can also affect caramelization. For example, adding a bit of acid, like lemon juice, can speed up the process, while adding milk or cream can slow it down. So why is understanding caramelization important? Well, think about it. Whether you're making a sweet caramel sauce, roasting vegetables, or baking a loaf of bread, understanding how and why caramelization happens can help you control the process and make your food taste better. Let's move on to a culinary phenomenon. It's a little less sweet, but just as fascinating. The Maillard reaction. Named after the French chemist who first studied it, the Maillard reaction is what gives brown food its distinctive flavor. Think about the delicious crust on a perfectly seared steak, the golden hue of a pan-fried dumpling, or the rich taste of coffee. All these are results of the Maillard reaction.
Now, what?
In fact, it's often referred to as the flavor reaction because of the depth and complexity it adds to food. So how does this reaction work? Well, it's a chemical reaction between amino acids and reducing sugars, usually requiring heat above 285 degrees Fahrenheit. During the Maillard reaction, hundreds of different flavor compounds are created. These compounds, in turn, break down to form yet more new flavor compounds, and so on. But here's the interesting part. The exact flavor that the Myard reaction gives off depends on the type of food, the temperature, and the cooking time. So, as you can imagine, it's a pretty complex process. Now, how can you control the Myard reaction for optimal results? Well, there are a few ways. Firstly, higher cooking temperatures promote the Maillard reaction. So, if you want that nice brown sear on your steak, you need to crank up the heat. Next, the pH level of the food can also affect the Maillard reaction. Alkaline environments enhance the reaction, so adding a bit of baking soda to your onions can speed up their browning when you're making a French onion soup. Lastly, the moisture level of the food also plays a role. The Maillard reaction is inhibited by the presence of water, so drier food browns more quickly and thoroughly. So there you have it. The Maillard reaction. It's a complex process, but understanding it can truly take your cooking to the next level. So now let's shift our focus to the main players in your food. Proteins, fats, and carbohydrates. These are the nutrients that not only fuel our bodies, but also undergo fascinating transformations during cooking. Starting with proteins, these molecules are made up of amino acids, and they are responsible for the structure and texture of many foods. When you cook proteins, they denature or change shape, which can alter the texture of your food. For example, think about an egg. It starts off liquid, but as you heat it, the proteins coagulate or come together, and the egg becomes solid. Next, let's talk about fats. Fats add richness, moisture, and flavor to dishes. They can also conduct heat and help foods cook evenly. When heated, fats can undergo a number of reactions. Some fats, when heated to a high temperature, can break down into smoke, a process known as the smoke point. Others can oxidize, which can create off flavors. Now, on to carbohydrates. They are the sugars, starches, and fibers found in fruits, grains, vegetables, and dairy products. When you cook carbohydrates, they can undergo a variety of reactions. For example, starches gelatinize, or absorb water and swell, which can thicken sauces or turn your pasta al dente. Sugars, as we discussed earlier, can caramelize, adding sweetness and a beautiful brown color to your food. Understanding how proteins, fats, and carbohydrates react under different temperatures and cooking methods can help you manipulate your ingredients to achieve your desired results. Want a crispy, brown crust on your steak? That's the Meyered reaction at work, which involves both proteins and sugars. You want your sauce to be thick and glossy? You'll need to understand gelatinization, a reaction that involves starch, a type of carbohydrate. So, in essence, Every time you step into the kitchen, you're not just a cook, you're also a chemist, manipulating molecules to create delicious dishes. Isn't that amazing? It's like your own edible science experiment. Now that's what I call tasty science. All right, now we're going to explore something that may sound a bit fancy, but trust me, it's something you encounter regularly in your kitchen. We're talking about emulsions. So what is an emulsion? Well, at its most basic level, an emulsion is a mixture of two liquids that don't naturally mix, like oil and water. Think about your vinaigrette, mayonnaise, or even butter. These are all examples of emulsions in cooking. Emulsions are fascinating because they allow us to mix the unmixable and create a stable, homogeneous mixture. This is possible due to the presence of an emulsifier, a substance with properties of both oil and water. In food, common emulsifiers include egg yolks, mustard, and even certain types of starches. Now, how does an emulsion contribute to the texture of certain dishes? Well, emulsions are all about creating a certain mouthfeel or texture. For instance, think about the creamy, thick texture of mayonnaise or the light, airy texture of whipped cream. These textures are a result of emulsions. But here's the tricky part, creating a stable emulsion. This requires a delicate balance. Too much force, and your emulsion can break or separate. Too little force, and your emulsion won't form. The key is to add your oil, or whichever ingredient is in lesser quantity, slowly and steadily into your water-based ingredient, while constantly whisking or blending. This allows the oil droplets to disperse evenly amongst the water molecules, creating a stable emulsion. So there you have it, the science of emulsion, simplified. It's just one more way. Understanding the chemistry of cooking can bring your culinary game up a notch. So the next time you're mixing up a vinaigrette or whipping up some mayo, remember, you're not just cooking, you're creating an emulsion.